and welcome to the video that I am hosting for second hour students who were gone today, or for those of you who just wanted to hear the sound of my voice again and learn about elements again and hopefully make it click like a Lego in your brain. The first thing we did in second hour today was the synapse second. It started with a conversation of elements and compounds. You're going to notice as we go forward that our daily science is going to start to be a little bit more random as we are preparing for the state assessment. Don't forget that that will be the 2 days after, actually 3 days after we come back from spring break. So we kind of start with this, which seems random at first, but is really going to help us to concrete the why we've been learning organelles. So number one, elements are the smallest particles of an atom. What do you think? True or false? If you picked false, you are correct. Now this is one of those statements where they want you to change the false statement, if it is false, to make it true. How could we do that? Well, two ways. One, the lazy way. Elements are not the smallest particle of an atom, but that's a little bit lazy. You can do better than that. So I could change it to atoms are the smallest particle of an element. As hopefully you remember from 6th grade, elements are made up of atoms, and atoms are the things that make everything up. So an atom is going to be the smallest particle of an element. Now, I know, and you know, that there are things even smaller than atoms. During the 60s, some scientists out in California discovered something called a quark. A quark comes in different flavors. Yes, that's right. It was the 60s and they called them flavors. Anyway, these different flavors of quarks deal with things like up, down, strange, charm. They're an interesting bunch. But anyway, for the state assessment and for today, all you need to know are atoms. So I'll go ahead and erase quarks for you. Number two, atoms combine with other atoms to form molecules. What do you think? It is true. Atoms do combine with other atoms to form both molecules and compounds. Number three, atoms can be rearranged in a chemical reaction. Rearranged. That is also true. What about number four? Atoms can be destroyed in a chemical reaction. Can they be destroyed completely? The analogy I used in class was disgusting. I will draw you a picture. What I asked them was, if you took your arm, here's for your fingers, and a thumbs up for science. If you took your arm and you rubbed it against the table repeatedly, what would happen? Well, eventually it would bleed, and then you'd have bone grinding against the table and little bits of you all over the place. But it would not go away. It would just change its formation. Atoms are the same way. So this one's going to be false. I know, the example was gross, and I apologize, but it's the one I used in class, so let's be real. Atoms can't be destroyed, they just change. Dealing with conservation of mass, conservation of momentum, conservation of energy. Scientists really like to conserve things. We really like to recognize that things don't ever go away, they just change shape. Number five, molecules can be broken down in a chemical reaction. Broken down, that is true. Molecules can be created. New molecules can be created in a chemical reaction. That is also true. In these two, when we're talking about breaking them down, we are talking about nuclear fission. When we are talking about building them up, we are talking about fusion. Put your hands together. Fusion. Put your hands apart. Fission. Yes, did you do it? Fuse them, fizz them. Use them, fizz them. Fusion is putting them together. Fission is breaking them apart. Chemical symbols. Hopefully you remember last year maybe what the letter C stood for, or what the letter O stood for. A chemical symbol is a letter combination that stands for an element. So, ooh, can I spell lithium? It's going to be a letter combination that stands for an element. A lot of times, such as AU for gold, the letters will be different than the letters in the actual word. This has to do with the fact that a lot of the scientists either chose Latin, which was a common language at the time, or they used their own native language, such as German. The other thing about a chemical symbol is it's really cool if you're able to sing the element song or say them all in order. But at the end of the day, what's most important when it comes to chemistry is knowing how those things come together and work together. So speaking of chemistry, as we move forward, in your book on page 22, there's this diagram that deals with the back of a camel's back. Your body is made up of only 4 organic compounds, and fat is one of them. So the question asks, how do you think the camel might be effective if it didn't have humps? Well, it wouldn't be able to live like it normally does. It wouldn't have this homeostasis about it. So your body needs all of the elements and all the compounds to work in all of the ways we know how. So let's go back to that very beginning. Like I said, it's going to build on the bell word. An element in your spiral, an element is any substance that cannot be broken down into smaller substances. A compound is when 2 or more of those elements combine together. The third one that I didn't have on the board, but it is a molecule. A molecule is, or molecules form, when 2 or more atoms combine. So for example, if you had a helium atom and you added an oxygen atom, this would be a compound, and it would also be a molecule, because you have one element and a second element, so you have 2 or more elements. But remember, our definition of a molecule was more than 1 or 2 atoms. So you have 1 atom, 2 atoms. Over here, you can have another oxygen plus an oxygen. So you don't have a compound because they're the same element. You do, however, have a molecule. It's kind of like that rule in math where a square and a rectangle are related to one another but not necessarily the same thing. Think along those lines. Last but not least, we have another diagram in your book. How many atoms form a water molecule? H2O makes up water. So you have 1 atom of hydrogen. You have 2 atoms of hydrogen and 1 of oxygen, making a total of 3. We'll review this a little bit more tomorrow if you're still confused. With carbon dioxide, you also have 3 because you have carbon, and you have 1 of those, that's going to be our gray, and then you have oxygen, and you have 2 of those. Alrighty, I hope you have a wonderful evening. Tomorrow we will pick up with our conversation of chemistry, go a little bit more in depth, and we will also be talking about the chemicals that are most important because they are the ones that make up you. Have a great night.